Assalamu alaikum students. In the last lecture we discussed mirror formula and linear magnification. Today we would go through the numericals based on mirror formula and linear magnification. So numericals based on mirror formula and linear magnification. Let's go through the first numerical. An object is placed at a distance of 10 centimeter from a convex mirror of focal length 15 centimeter. An object is placed at a distance of 10 centimeter from a convex mirror of focal length 15 centimeter. Find the position and nature of image. Find the position and nature of image. First we will go through the given values. We are given with an object placed at a distance of 10 centimeter. That means an object has been placed at a distance of 10 centimeter from the mirror. An object has been placed at a distance of 10 centimeter from the mirror. That means this 10 centimeter is the object distance. Object distance is denoted by U is equal to 10 centimeter. But we know as per sign conventions, an object distance is always taken as negative. Remember it, whether it's a concave mirror or convex mirror or lens, an object distance is always taken as negative. So we would write it as minus 10 centimeter. Okay, the next value given, a convex mirror. You should also remember the mirror given in order to know the sign to be put before focal length. So here the focal length is given as 15 centimeter. Focal length is 15 centimeter. But the focal length is of concave or convex? It is of convex, so it would be taken as positive. So whether I write plus in front of it or not. So focal length is plus 15 centimeter because it's a convex mirror. Now what we have to calculate? We have to calculate the position and nature of the image. The position, whether the image is formed in front of the mirror or behind the mirror, and the nature of the image, whether the image is real, inverted or whatever. Fine? Okay. So you just write down the numerical first and the given values. Okay. Now we would solve this numerical. We have the formula 1 by V plus 1 by U is equal to 1 by F. 1 by V plus 1 by U is equal to 1 by F. Here we had a formula. Which of the two values are given? U and F, isn't it? U and F are given. So I would transpose it. 1 by V is equal to 1 by F minus 1 by U. 1 by V, I have to calculate V. I would put it on left hand side and I would transpose 1 by U, which would come to be minus. Fine. So 1 by V is equal to 1 by F minus 1 by U. Now I would put the values. 1 by V is equal to 1 by F. F is given to be 15 centimeter minus 1 by U minus 10 centimeter, isn't it? So 1 by F is given in the question as 15 centimeter and U object distance is given to be minus 10 centimeter, and we put a sign of negative before it as per sign conventions. Okay. 1 by V is equal to, whether you cross multiply it or you would go through the LCM procedure, one and the same thing. 1 into minus 10 is minus 10, minus would remain as it is. 1 into 15 is 15 divided by 15 into minus 10 is minus 150. Fine. 1 by V is equal to minus is plus, so minus 25 divided by minus 150. Fine. Minus would cancel out. It is 1 by V, we would reciprocate it. So V is equal to, here also the reciprocal would take place. 150 by 25. 150 by 25 is equal to 6 centimeter. So the value of V is plus 6 centimeter. So the image distance is plus 6 centimeter. As I have discussed earlier that if the image distance comes out to be positive, if the value of image distance comes out to be positive, the position of images, I would write the position of images behind the mirror and its nature is, the image distance is positive, it means the position of image is behind the mirror and its nature is virtual and erect as per the assumptions and sign conventions. So the numerical is done, the image distance comes out to be 6 centimeter and the position of image, as the image is with the help of the V, we can know with the help of this simple numerical value, we can know the different characteristics of image. So here are the characteristics of image. The image distance is positive, so the position of image is behind the mirror and the nature of the image is virtual and erect. Fine. So you just have to know first the given values and you have to give them the proper signs. Positive, negative, like the object distance which is always taken as negative, and you have to see in numerical whether you are given with the concave mirror or convex mirror, and in case of a convex mirror the focal length is taken as positive. If you are given with the concave mirror, then the focal length is to be taken negative, but the object distance is always taken as negative. And when you get the value of V, if the value of V comes out to be positive, then the position is behind the mirror and the nature is virtual and erect. And if the value of V comes out to be negative, then the position is in front of mirror and the nature is real and inverted. Let's go through the other numerical, you would get it there. Write down the numerical. An object of size 7 centimeter an object of size 7 centimeter is placed at a distance of 27 centimeter in front of a concave mirror of focal length 18 centimeter. Find the position, nature and size of the image. Find the position, nature and size of the image. An object of size 7 centimeter is placed at a distance of 27 centimeter in front of a concave mirror of focal length 18 centimeter. You have to calculate three factors. First, the position, the nature of the image and the size of the image. In the previous numerical, we had to calculate only position and nature, which we would get with the help of V. But now we have to calculate the size of the image as well. So first we will write down the given values. An object of size 7 centimeter. What is this 7 centimeter? It is the size of object denoted by H1. So H1 is given here as 7 centimeter. The size of the object is given to be 7 centimeter. Okay, is placed at a distance of 27 centimeter. That means this object of size 7 centimeter has been placed at a distance of 27 centimeter in front of a concave mirror. So the object distance is given 27 centimeter. But we already know that the object distance is always taken as negative. Fine. Okay. And the focal length is 18 centimeter. In order to give sign to the focal length, we have to know which type of mirror it is, and this mirror is concave mirror. and the focal length in case of a concave mirror is taken as negative. So focal length here is negative. So we are given with these three values: the height of the object or the size of the object or the length of the object as 7 centimeter, and the object distance as 27 centimeter. As object distance is always taken as negative, I put the sign of negative in front of it. Okay. Focal length 18 centimeter, as it's a concave mirror, so the focal length is taken as negative. Fine. Let's solve this numerical now. We would write down the mirror formula first. One by V plus 1 by U is equal to 1 by F. 1 by V plus 1 by U is equal to 1 by F. Fine. We are given with U and F. We have to calculate V. So I would isolate V as it is 1 by F minus 1 by U. I transposed 1 by U here and it is minus 1 by U. Now I would put the values. Okay. 1 by V is equal to 1 by F. The value of F is 18 centimeter, but this time it is minus 18 centimeter because it's a concave mirror. Minus 1 by U. U is object distance and U is given to be minus 27 centimeter. Fine. Okay. So here 1 by F, F is minus 18 centimeter, minus 1 by U, U is minus 27 centimeter. Okay. 1 by V is equal to 1 into minus 27 is minus 27. Here the minus remains. 1 into minus 18 is minus 18. Fine. Divided by minus 18 into minus 27 centimeter. Fine. 1 by V is equal to minus 27, minus into minus is plus 18, divided by minus 18 into minus 27. Fine. Let's here it is 1 by V. We would put it as V. V is equal to, the reciprocal would take place here, minus 18 into minus 27 divided by minus 27 plus 18. So when you would solve this, the value of V would be minus 54 centimeter. Fine. Minus 18 into minus 27 divided by minus 27 plus 18. So the value of V would come out to be minus 54 centimeter. So now the image is formed at a distance of 54 centimeter from the mirror, but V is minus. V is minus, image distance is minus. What does this signify? That the position of images, V is minus. So the position of images in front of mirror. Now the nature, V is minus. So the nature of image is real and inverted, as per the sign conventions and assumptions. Fine. Okay. So the image distance comes out to be minus 54 centimeter, and this simple numerical value is giving me the different characteristics of image. With the help of this simple numerical value, I got to know that the image is formed at a distance of 27 centimeter from the mirror. Image, for example, this is an image which is formed at a distance of 27 centimeter from the mirror. Fine. And the position of this image is behind the mirror and in front of mirror, and the nature of image is real and inverted. Fine. Now we have to calculate the size of the image. In order to calculate the size of the image, we know the formula: H2 is equal to minus V by U into H1, isn't it? The relation between linear magnification and mirror formula. Okay. H2 is equal to minus the minus of formula, and the V, the value of V is minus 54 into H1. H1 is already given 7 centimeter. Fine. Divided by U. U is also given minus 27. So H2 is equal to minus into minus is plus 54 into 7 divided by minus 27. So H2 is equal to, when you would solve this, it would be minus 14 centimeter. So the height of the image is 14 centimeter. Fine. Okay. So with the help of this simple numerical value, we got to know that the position of the image is behind the mirror and its nature is real and inverted. Then we had to calculate the size of the image. With the help of this simple formula, we got to know the size of the image. So in order to know the position, nature and size of the image, you have to use only two formulas, only two. The first is mirror formula and the second is relation between magnification and mirror formula. These two formula you have to remember. First you have to calculate V. With the help of V you would know the position and nature of the image, and then you would calculate simply H2 with the help of this formula. So here is the position of image, nature of image, and here is the size of the image. Now you can solve the numerical. Let's go through the other numerical based on the same formulas. Write down the numerical. An object of size 5 centimeter, an object of size 5 centimeter is placed at a distance of 20 centimeter in front of a convex mirror, of radius of curvature 30 centimeter. Find the position, nature and size of the image. Find the position, nature and size of the image. So you are given with the size of the object again, that is 5 centimeter. So H1 is equal to 5 centimeter. Is placed at a distance of 20 centimeters. So this object has been placed in front of a convex mirror. It is placed in front of a convex mirror at what distance? At a distance of 20 centimeter. Object distance 20 centimeter. As per sign conventions, I have to put minus sign in front of it. Fine. Okay. In front of a convex mirror of radius of curvature is given, that is 30 centimeter. In the previous numericals, we were given with the focal length, but in this very numerical, we are given with the radius of curvature. So you can simply use that formula. 1 by V plus 1 by U is equal to 2 by R. Simply this formula. Or you can first calculate the focal length. We know F is equal to R by 2. Here R is 30 centimeter, 30 divided by 2. So F is equal to 15 centimeter. Fine. So you can write as F is equal to 15 centimeter. Now the question is same as that of previous one. You are given with H1, you are given with U, you are given with F, focal length. You are given with the radius of curvature, but the radius focal length is equal to radius of curvature divided by 2. So we calculate the focal length with the help of that formula. So we got the focal length. So again we have H1, U and F. With the help of these given values, we can calculate the position of the image, the nature of the image and the size of the image. Let's say I would write the formula 1 by V plus 1 by U is equal to 1 by F. 1 by V is equal to 1 by F minus 1 by U. Fine. 1 by V is equal to F is given, F 15 centimeter, it's a convex mirror, so F would be plus, okay, minus 1 by U. U is also given, that is 20 centimeter minus 20. Fine. So 1 by V is equal to 1 into minus 20 is minus 20, minus 1 into 15 is 15, divided by 15 into minus 20. Then you have to go for the reciprocal, so you would get the value of V. Then you have to go through that formula, H2 is equal to minus V by U into H1, so you would get the value of H2. Just like we solved with the previous numerical, you have to do likewise, and you would get the value of V and H2. And if the value of V comes out to be positive, position is behind the mirror and nature is virtual and erect. If the value of V comes out to be negative, then the position is in front of the mirror and the nature is real and inverted. And with the help of this formula, you can get the value of H2. Hope you can solve any numerical based on mirror formula and linear magnification. Okay, this was the end. This is the end of the lecture. The numericals based on mirror formula and linear magnification. We will discuss the next part of the chapter, that is refraction of light, in the next lecture, inshallah. Thank you.